From space, Antarctica appears as a vast white heart at the bottom of our world. It's a place of sublime and silent beauty, a continent of ice that seems almost entirely devoid of life. Its surface is a desolate expanse, scoured by winds that can reach speeds of over 200 miles per hour, and plunged into temperatures that can plummet to an astonishing -90 degrees Celsius. This is the coldest, driest, and highest continent on Earth, a place so extreme that it can feel like another planet entirely. Yet, this vision of emptiness is a grand illusion. The pristine, static surface that we see is merely a mask, concealing a world of unimaginable dynamism, complexity, and life. Beneath that seemingly endless sheet of white lies a secret continent, a realm that we are only just beginning to comprehend. The ice itself is a monumental feature, in some places reaching a thickness of nearly 5 kilometers. This colossal frozen reservoir holds an incredible 70% of all the fresh water on our planet, a resource of immense global significance locked away in a crystalline state. If this ice were to melt, it would raise global sea levels by a catastrophic degree. But the ice is not just a static block, it is a living, moving entity, a glacier of continental scale that flows, grinds, and shifts, shaping the land hidden far beneath it and influencing the very climate of our world. This frozen world is not just a geological marvel, it is a place of profound scientific importance and burgeoning geopolitical tension. For decades, it has been a continent dedicated to peace and science, governed by an international agreement that sets aside territorial claims and prohibits military activity. However, the world is changing, and the pressures of resource scarcity and strategic positioning are beginning to press in on this remote sanctuary. The secrets that lie dormant under the ice are not only scientific but also potentially economic, and as nations look to the future, the allure of what might be hidden there is growing ever stronger. Antarctica's isolation is no longer a guarantee of its protection. The story of Antarctica, therefore, is a tale of two worlds. There is the world we can see, the majestic icebergs, the hardy penguins huddled against the cold, the breathtaking vistas of white stretching to the horizon, and then there is the hidden world, the one that exists in the crushing pressure and absolute darkness beneath kilometers of ice. It is a world of liquid water, of surprising warmth, of undiscovered life, and of clues to our planet's deepest past and its uncertain future. To truly understand Antarctica, we must look beyond the surface and venture into the profound and mysterious depths that lie beneath. It is a staggering thought that beneath the immense weight of Antarctica's ice, there exists a world that is not frozen at all. Instead, it's a dynamic landscape of liquid water, a vast and interconnected plumbing system that has remained hidden from human eyes for millennia. Scientists have discovered a complex network of thousands of subglacial rivers and hundreds of lakes, some of which are vaster than any city. This hydrological system, sandwiched between the bedrock of the continent and the ice sheet above, forms a world unto itself. Here, in the perpetual dark, water flows, pools, and travels, carving channels and sustaining environments completely cut off from the sunlit world. The scale of this subglacial hydrology is difficult to overstate. Some of these hidden lakes, like Lake Vostok, are truly enormous, comparable in volume to the Great Lakes of North America. The rivers that connect them are just as remarkable, with some flowing uphill against gravity, forced onwards by the immense and uneven pressure of the ice sheet above them. These are not gentle, meandering streams. They are powerful systems that can drain with astonishing speed. Scientists have observed events where entire lakes have emptied in a matter of days, releasing billions of liters of water and causing the ice surface kilometers above to suddenly drop and settle by several meters, a testament to the immense forces at play. This hidden world is not just water, it is also a place of fire. The continent is home to active volcanoes, including Mount Erebus, the southernmost active volcano on Earth. The heat from this geothermal activity melts the base of the ice sheet from below, creating a network of warm caves and contributing to the liquid water systems. Within these volcanically heated caves, a world away from the freezing temperatures on the surface, scientists have found something extraordinary. Life. Mosses, algae, and other microscopic organisms thrive in these impossibly remote oases of warmth, their DNA suggesting they may be species entirely new to science, having evolved in isolation for countless generations. This discovery of life in such an extreme environment challenges our very understanding of where life can exist. In the total darkness of a subglacial lake, drilled into after being cut off from the outside world for thousands of years, scientists were astonished to find a tiny crustacean, an amphipod, swimming freely in the water. These creatures are living in a world without light, under immense pressure, and with nutrient sources that are still a mystery. It proves that life is tenacious, resourceful, and can find a foothold in the most unlikely and inhospitable corners of our planet, a hidden biosphere that has persevered against all odds. The Antarctic ice sheet is far more than just a colossal mass of frozen water. It is a perfect and irreplaceable archive of our planet's history. Every year, snow falls on the continent, and because it so rarely melts, it accumulates layer upon layer. Over thousands and then millions of years, the immense weight of the overlying snow compacts these layers into dense ice. As this process unfolds, tiny bubbles of the atmosphere at that time are trapped and sealed within the ice. Each of these bubbles is a perfect microscopic time capsule, a pristine sample of Earth's ancient air, preserved for eternity. By drilling deep into the ice, scientists can extract long cylinders of this frozen history, known as ice cores. These cores are like books written in a language of chemistry and physics, and by carefully analyzing them, we can read the story of our planet's climate going back hundreds of thousands of years. The trapped air bubbles reveal the exact composition of the atmosphere, allowing us to measure past levels of greenhouse gases like carbon dioxide and methane. Chemical isotopes in the water ice itself act as a thermometer, telling us the average global temperature at the time the snow fell. It's through these remarkable frozen records that we know, with certainty, how closely our climate is linked to carbon dioxide. The information held within these cores is astonishingly detailed. Layers of volcanic ash trapped between the snowfalls allow scientists to pinpoint the dates of major eruptions around the world, helping to correlate climate events across different historical records. The oldest ice core ever recovered, drilled from a depth of nearly 3 kilometers, contains a continuous atmospheric record stretching back an incredible 1.2 million years. It is a library of planetary history that exists nowhere else on Earth, offering us a baseline against which we can measure the unprecedented changes we are witnessing in our climate today. This frozen library warns us of the consequences of our current actions. The fragility of this archive cannot be overstated. As our planet warms, the very integrity of the Antarctic ice sheet is under threat. If the ice were to begin to melt or its internal structure were to change, this priceless record could be blurred, corrupted, or lost forever. In some parts of Antarctica, ancient blue ice, which is hundreds of thousands of years old, is exposed at the surface by powerful winds that strip away the newer snow. Scientists can now access this incredibly old ice without deep drilling, but it also serves as a stark reminder that this ancient record is vulnerable, a precious and finite resource for understanding our world's past and navigating its future. While much of the subglacial world remains inaccessible, nature has provided us with a few spectacular windows into its mysterious workings. Perhaps the most famous and dramatic of these is blood falls, a phenomenon that looks like a bleeding wound on the pristine white face of the Taylor Glacier. For years, its origin was a puzzle. This 5-story-high cascade pours a vivid, blood-red liquid onto the ice of Lake Bonny below. The startling color is not due to algae, as was once thought, but is the result of a unique chemical process that offers a direct glimpse into the world beneath the ice. The source of blood falls is a subglacial reservoir of incredibly salty water, or brine, that has been trapped beneath the Taylor Glacier for perhaps millions of years. This water is more than twice as salty as the ocean, a property that prevents it from freezing even at temperatures as low as -5 degrees Celsius. Sealed off from the atmosphere and sunlight, in a world without oxygen, this ancient water became incredibly rich in dissolved iron from the bedrock it was in contact with. When this clear, iron-rich brine finally finds a fissure and seeps out to the surface, it encounters oxygen for the first time. The iron instantly oxidizes. It rusts, staining the water and the ice it flows over with that shocking crimson hue. Blood falls is more than just a geological curiosity. It is a natural laboratory. It provides scientists with a sample of a subglacial ecosystem without the need to drill through 400 meters of ice, a process that risks contaminating the pristine environment. Analysis of the water has revealed that it contains a diverse community of microbes that have survived for aeons in this dark, cold, and oxygen-free environment. These organisms appear to metabolize iron and sulfate compounds to survive, a strategy for life that seems truly alien. It demonstrates that complex ecosystems can be sustained for immense periods, completely isolated from the sun-powered world we know. This remarkable feature serves as a powerful illustration of the processes happening all across the hidden continent. Floodfalls is just one of many thousands of outflows, most of which occur unseen beneath the ocean along Antarctica's coastline. It proves that the subglacial river systems are actively transporting minerals and nutrients from the continent's bedrock towards the sea. The iron that stains the ice red at floodfalls is a vital nutrient for marine life. This single visible plume is a signpost, pointing to a vast and hidden continental plumbing system that plays a critical role in fertilizing the oceans that surround Antarctica and supporting life on a global scale. The influence of Antarctica's hidden world extends far beyond the confines of the continent itself. The vast network of subglacial rivers and lakes does not simply remain contained beneath the ice, it ultimately connects to the surrounding sea. Thousands of these subglacial outflows discharge their nutrient-laden water directly into the Southern Ocean, mostly along the seabed, hidden from our view. This process acts as a colossal fertilization system, injecting essential minerals, particularly iron, into the marine environment. This nutrient influx is the fundamental trigger for life in these polar waters, initiating a food chain that supports some of the largest creatures on our planet. The iron and other nutrients released from beneath the ice fuel massive blooms of phytoplankton. These are microscopic plant-like organisms that, just like plants on land, use photosynthesis to convert sunlight into energy. They form the very base of the oceanic food web. When the nutrient-rich meltwater reaches the sunlit surface waters of the Southern Ocean, these phytoplankton populations explode, creating vast green swirls that are visible even from space. These blooms are not just a local phenomenon, they're a critical component of the global carbon cycle, drawing enormous quantities of carbon dioxide out of the atmosphere as they grow. These phytoplankton blooms, in turn, provide the food for a creature of immense importance: Antarctic krill. Krill are small shrimp-like crustaceans that gather in colossal swarms, some so dense and extensive they can be seen from satellites. They are the central pillar of the Antarctic ecosystem, a single species that forms the primary food source for a breathtaking diversity of animals, including seals, penguins, fish, and seabirds. The sheer abundance of krill, made possible by the productivity of the phytoplankton, is what allows the Southern Ocean to support such a high concentration of life in such a cold and seemingly harsh environment. At the very top of this rich food web are the greatest animals ever to have lived: blue whales. These magnificent creatures, along with fin whales, humpbacks, and other baleen whales, migrate to Antarctic waters each year for one reason: to feast on the incredible abundance of krill. A single blue whale can consume up to 4 tons of krill in a single day. The survival of these giants is therefore directly linked to the health of the phytoplankton blooms, which are themselves dependent on the hidden flow of nutrients from beneath the Antarctic ice sheet. It is a profound connection, linking a secret world of dark, subglacial rivers to the largest animal on Earth. For over 6 decades, Antarctica has really stood as a beacon of international cooperation. You know, a continent reserved for peace and scientific discovery under the landmark Antarctic Treaty of 1959. This agreement ingeniously set aside all territorial claims, banned military activities, and prohibited mining, ensuring that the continent would be used for the benefit of all humanity. However, there's a crucial clause in this treaty that states it can be reviewed or modified by signatory nations from the year 2048. As this date draws nearer, the geopolitical climate surrounding Antarctica is, well, perceptibly shifting from one of pure cooperation to one of strategic competition. Nations like China and Russia are significantly expanding their footprint on the continent in what is becoming a silent race for presence and influence. They're building new, state-of-the-art, year-round research stations, often in strategic locations, and are conducting extensive seismic surveys, ostensibly for scientific purposes. The unspoken understanding is that a strong physical presence today could translate into a powerful negotiating position tomorrow. If the treaty's ban on resource extraction were to be weakened or overturned in 2048, control over territory could suddenly become immensely valuable, and these modern stations could become the footholds for future claims. The potential resources hidden beneath the ice and in the surrounding Southern Ocean are vast. The continent is believed to hold significant deposits of minerals and fossil fuels, while the ocean is rich in biological resources like krill. As climate change makes parts of the continent more accessible and global demand for resources grows, the economic temptation to exploit Antarctica becomes stronger. This has led to a palpable increase in tension, with nations subtly jockeying for position. In a clear sign of this, the United States recently conducted a series of unannounced inspections of foreign stations in early 2026, exercising its rights under the treaty to ensure compliance and project its own influence in the region. This geopolitical chessboard is not just about resources, it is also about strategic location. New seafaring routes may open through the Southern Ocean as ice recedes, and control of Antarctic gateways could hold significant maritime power. The scientific work itself, from mapping subglacial geology to monitoring climate, carries dual-use potential, providing data that is as valuable for resource prospecting as it is for pure research. The peaceful, collaborative spirit of the Antarctic Treaty is being tested as never before, and the decisions made in the coming decades will determine whether Antarctica remains a continent for science or becomes a new frontier for global conflict. Despite our growing understanding of Antarctica's hidden world, our direct access to it remains, honestly, astonishingly limited. The logistical challenges of operating in such a hostile environment are immense. The ice is kilometers thick, the pressures are crushing, and the temperatures are lethal. It's a sobering fact that the total area of the subglacial environment that human beings have physically reached, through boreholes drilled deep into the ice, is estimated to be no larger than a basketball court. Everything we have touched of this hidden continent could fit within a tiny, defined space, a minuscule sample of a landmass larger than Europe. Given these limitations, science has turned to remarkable technologies to peer through this frozen veil. Much of our knowledge comes not from direct contact, but from remote sensing. Scientists use aircraft equipped with sophisticated instruments, such as ice-penetrating radar and airborne electromagnetic sensors, to fly systematic surveys over the vast ice sheet. These technologies work by sending signals through the ice and analyzing how they bounce back. They allow us to differentiate between solid bedrock, liquid water, and frozen sediment, effectively creating a map of the world that lies beneath our feet without ever having to drill. These remote methods have been responsible for the biggest discoveries, revealing the true scale of the subglacial mountain ranges, like the Gamburtsev Mountains, and mapping the vast outlines of Lake Vostok and the intricate networks of rivers that connect it to other water bodies. More advanced systems can even detect the movement of water and the subtle changes in the ice sheet's thickness and flow. Furthermore, satellite observations from space provide the bigger picture, tracking the speed of glaciers as they flow towards the sea and measuring changes in the continent's overall ice mass, revealing that West Antarctica is losing ice at an alarming rate. However, remote sensing can only tell us so much. To truly understand the biology and chemistry of this hidden world, we must obtain physical samples. This has led to heroic feats of engineering, such as the clean drilling projects that have successfully penetrated subglacial lakes. These efforts require extreme measures to avoid contaminating the pristine environment, using hot water drills and sterilization techniques to ensure that the samples of water and life they retrieve are untainted. Each successful mission is a triumph of science and logistics, providing a precious, hard-won glimpse into a realm that has been sealed off from our world for millions of years. The extreme cold and preservative power of the Antarctic ice do not only hold records of the planet's natural history, they also entomb the fragments of our own. The continent acts as a vast, unforgiving museum, freezing moments of human endeavor and tragedy with perfect, chilling clarity. One of the most poignant examples of this is the wreckage of Air New Zealand Flight 901. In 1979, this sightseeing flight crashed into the slopes of Mount Erebus during whiteout conditions, tragically killing all 257 people on board. The remote location and treacherous moving ice made a full recovery of the aircraft and its victims impossible. Today, parts of the fuselage and other debris from the crash remain entombed within the glacier. As the ice of Mount Erebus slowly grinds its way towards the sea, it carries these fragments with it, a somber memorial preserved in a frozen, moving grave. The wreckage serves as a stark reminder of the unforgiving nature of the Antarctic environment and the human costs that can accompany our exploration of it. It is a human story, frozen in time, that will remain part of the continent's fabric for centuries to come, a modern fossil encapsulated within the ancient ice. This power of preservation also extends to the legacy of early polar exploration. The huts built by heroic age explorers like Robert Falcon Scott and Ernest Shackleton over a century ago stand today in a remarkable state of preservation. Inside, tins of food, scientific equipment, and personal belongings remain exactly as they were left, protected from decay by the dry, frigid air. These sites are not just historical curiosities, they are time capsules that offer an intimate connection to the immense hardships and unwavering spirit of the first people to venture into this land. They are a testament to human resilience, standing in stark contrast to the modern, high-tech stations of today. This ability to preserve the past holds a mirror to our future actions. Just as the remnants of past tragedies and triumphs are locked in the ice, so too will our current impact be recorded. The plastics, chemicals, and carbon emissions from our industrialized world are already being deposited in the annual snow layers, forming a new, distinct stratum in the ice core record for future generations to find. Antarctica not only shows us our deep past, but also reflects our present. The human imprint, whether it is the wreckage of a plane, the hut of an explorer, or the microscopic traces of pollution, becomes a permanent part of this continent's story. The hidden world of Antarctica, with its subglacial rivers, ancient ice and undiscovered life, is not merely a scientific curiosity. It is a critical component of our planet's operating system, and its fate is inextricably linked to our own. The discoveries being made, they are fundamentally reshaping our understanding of Earth's climate, the limits of life, and the intricate connections that bind our global ecosystem together. The secrets that are being unlocked from beneath the ice are not just about the past. They are vital warnings and guideposts for the future we are now creating. The health of the Southern Ocean, which is the engine for so much of the planet's marine biodiversity, depends directly on the stability of the Antarctic ice and its hidden plumbing. From the microscopic phytoplankton to the magnificent blue whales, this entire ecosystem is balanced on a flow of nutrients controlled by ice and water dynamics we are only just beginning to map. As climate change accelerates the melting of the ice sheet, this delicate balance is threatened. The rate and composition of this nutrient flow could change, with unpredictable and potentially devastating consequences for marine life worldwide. At the same time, the continent stands at a geopolitical crossroads. The international cooperation that has defined Antarctica for over half a century is facing its greatest test. As the 2048 treaty review date approaches, the world must decide whether to reaffirm the continent's status as a global commons for peace and science, or to allow it to descend into a new theater of competition and exploitation. The path we choose will be a powerful indicator of our ability as a global community to manage shared resources and prioritize long-term environmental stewardship over short-term national interests. The future of Antarctica is a barometer for the future of world peace. Ultimately, the great white continent at the bottom of the world holds our past, reflects our present, and contains the keys to our future. It is a library of planetary history, a cradle for unique life, a driver of global ocean currents, and a symbol of human cooperation. The secrets hidden beneath its ice matter profoundly, for the future of scientific knowledge, for the health of our oceans, and for the legacy of peace we leave to generations to come. Protecting this last great wilderness, in all its visible and hidden glory, is one of the most important responsibilities we face today.